In this major overhaul of an aircraft engine, your job will be to clean the parts of the disassembled engine, inspect and repair them, and check all specified clearances against the table of limits. To review quickly the disassembly procedure, you'll recall that the engine was removed from the airplane and mounted on an engine stand. Then it was disassembled. The cylinders and pistons were removed. The oil sump was also removed from the crankcase. Then the gear case cover. And finally, the two halves of the crankcase were separated to get at the insides of the engine. This made it possible to lift out the crankshaft and connecting rods and the other internal part of the engine. With the engine torn down, your first job is to clean every last part thoroughly. Scrub all the smaller parts, like connecting rods, in a tub of cleaning solvent. Use a stiff brush to do a thorough job. When you finish cleaning the small parts, dunk the crankshaft in the... A brush will help you clean in around the throws, journals, and bearing surfaces. When you dry the shaft with the compressed air gun, use the airstream to blow out and clean the oil passages in the crankshaft. This is a must in engine overhaul. Clean both halves of the crankcase, inside and out. It's a good idea to dip the whole thing in a cleaning solvent. All the dirt, oil, and sludge that gather on the metal must be removed. When it's clean, dry the crankcase off carefully with compressed air. Be very sure the oil passages in the case are clear. Blow them out with air and cleaning solvent. Before cleaning the oil sump, make a careful search for metal particles that may have chipped off the engine. Wipe out the inside with a clean rag. Loose particles of metal might be a clue to serious trouble in an engine. If you should find any chips like this, determine the kind of metal and look for the cause. Clean every part you've disassembled with equal thoroughness. Cleaning of all the engine parts not only makes your inspection more efficient, but it allows you to check clearances with greater accuracy. When all your cleaning is finished and the parts shine like new, you're ready to inspect the crankshaft. The crankshaft is the most vital part of any engine, and it must be in perfect condition. First in order is a visual inspection of the shaft. Inspect the propeller nut threads. Look for cracks, scores, or other damage. Inspect the propeller key for burrs or signs of wear, and check it in the keyway to be sure it fits properly. This should be a very snug fit. Ordinary visual inspection of the crankshaft is not enough, however, as fractures can't always be seen. The use of some kind of particle inspection is a more certain test. In the magnetic particle inspection, the crankshaft is magnetized by sending a charge of electric current through it. The shaft is then thoroughly soaked with a solution containing magnetic particles. If there's a fracture, the particles contained in the solution will adhere to the edges of the fracture and make it visible. This shaft is in sound shape, since there is no indication of cracks. So that you will recognize a fracture when you see it, here's a fractured shaft from another engine. Notice how the particles cling to the line of the crack and bring it into relief. A fractured shaft must be replaced. When the inspection is complete, the shaft must be demagnetized by moving it back and forth inside a coil chamber and then removing it slowly. But you must be certain, too, that the shaft is not out of alignment. A stand like this is most efficient for this test. A dial indicator put on the shaft will check it for run-out or straightness when the shaft is rotated. Make this check with the indicator on the end of the shaft. Make another check with the indicator on the center main bearing surface. The needle on the dial shouldn't vary more than is allowed by your table of limits. You can check in your engine manual for the maximum run-out allowance. On this engine, it's 5/1000ths of an inch. Now you need to measure the 7 bearing surfaces of the shaft in order to determine clearances. On this shaft, there are 3 main bearing surfaces where the shaft rotates on the bearings in the crankcase. There are also 4 bearing surfaces where the connecting rods are attached to the shaft. Use a micrometer of the right size to measure the diameter of the shaft. The purpose of these measurements and checking of clearances is to discover wear that wouldn't be visible to the eye. Take a measurement in 2 directions to check for out of round. If there's a slight difference in the reading in different positions on the shaft, record the smaller diameter on your check sheet. The next bearing surface is for a connecting rod. Measure this diameter in the same way and record the smaller measurement. Later, you'll measure the connecting rod bearing and, by subtraction, get the clearance. Now measure each of the other 5 bearing surfaces and record the diameters. When that's done, you're finished with the crankshaft for the time being and can go ahead with an inspection of the connecting rods. Take the rod apart and slip the bearing out. Check the bearing seat for cracks, nicks, or scores. Examine the split bearings for scores, chipping, or flaking. Give the rod itself a careful checking over. Here's a bearing that's scored. This score is deep enough so the bearing will have to be replaced. These split bearings are always replaced in pairs, not individually. The bearings fit easily into the seat, and they'll only go in one way. You can't go wrong. So far, this rod is in good condition. Bolt it back together so you can give it a check for possible bend or twist. To make this check, insert a special mandrel through each of the holes in the rod, using shafts that fit snugly. To make the check accurately, tighten the nuts with a wrench. Now prepare a set of parallel bars with 4 metal gauge blocks on a surface plate. Then rest the ends of the mandrels on the blocks like this. Now compare the distance between the ends of the mandrels on each side of the rod. Use a dial indicator for accuracy. The dial indicator reading should be exactly the same on each side of the rod, if the connecting rod is perfectly straight. Now make a check for twist. If the ends of the mandrels rest firmly on the gauge blocks and there's no wobble at the corners, the rod is not twisted. With all the connecting rods inspected and with damaged part replaced, next measure the bearings at each end to obtain clearances. Before doing that, however, let's be sure of the clearances we're after. You've already measured the diameter of the crankshaft at the 4 throws where the connecting rods fit. Now you want to measure the diameter of the bearing in the large end of the connecting rod. Then, by subtraction, you can find out what the clearance is between the crankshaft and the connecting rod bearing. In operation, the crankshaft is nearly centered in the rod, like this, with clearance for oil all the way around. Of course, when you check the clearance, your figure will represent the total, as if the rod were pushed to one side. Now make the measurements. Use a telescoping gauge and micrometer to measure the diameter of the bearing through which the crankshaft fits. Take your measurement in more than one direction, and if there's a slight variation, use the larger diameter. Now, to figure the clearance between the crankshaft and the connecting rod bearing, subtract to get the difference. Check this clearance with that given in the table of limits in your manual. Your clearance is satisfactory. The bearing in the small end of the connecting rod where the piston pin fits also needs to be measured. Measure this diameter in more than one direction, and if there's a difference, use the larger diameter. Record this measurement, and you can obtain the clearance between the piston pin and the bearing. You'll remember that you measured the diameter of the piston pin when you overhauled the pistons. Now you can get the clearance between the piston pin and the bearing in the small end of the connecting rod by subtracting one diameter from the other. Now look up the allowable clearance in the table of limits in your engine manual. Your clearance is okay. Give each of the 4 connecting rods an equally thorough examination and measure the bearing diameters in the same way. You've now completed your inspection of the crankshaft and connecting rods. The camshaft, the 2 halves of the crankcase, and the other disassembled parts remain to be overhauled before the engine can be reassembled.